Today's lesson, we're going to finish the back side of the notes paper. We're going to focus on, or I should say, we're going to sort of touch on how the graph of a quadratic equation relates to what we just did yesterday. So we're just going to kind of touch on this. It's something that we'll come back to, but I want you to see what we can now do with a parabola. I'm sure you're excited, but the truth is we're ready to keep adding to what we're learning. By the way, after this brief little follow-up on the notes, then we're going to practice what we did yesterday. You should be able to find that practice. If you're absent, you should be able to find that still in the calendar links, so make sure that you check that out. But what we want to do is we want to make a connection with graphing a quadratic, graphing a parabola. All right, now in order to do this, the good news is all the things that we learned about a parabola prior are still true. Like starting with the vertex. The vertex is going to be the opposite of b over 2a. Yeah, you haven't forgotten, have you? So that's going to be the opposite of 2 over 2 times 1. Well, that just works out to be negative 2 over 2, which is negative 1. Now remember, that's just the x value of the vertex. The y value comes from plugging in negative 1. And if I plug in negative 1, I'm talking about plugging it in to the original equation. And you always want to be careful when you're plugging in, especially a negative number, especially when we start getting into some extra order of operations here. So negative 1 squared. Yes, that's positive 1. Then we get negative 2 minus 8. And if you do those, the arithmetic there very carefully and correctly, you get negative 9. Okay, now what we just found is the vertex at negative 1, negative 9. Nothing too super duper yet. In other words, we've done that plenty of times. How about the y-intercept? The y-intercept, that's what happens when you plug a 0 into the equation for x, right? Yeah, if you plug a 0 into the equation, you just get the last number. You get negative 8. So that's usually pretty easy, and that has not changed. But we don't need to do a lot of work to get that value. Now, what we could do is we could start, talking about graphing what we have found. So I got to graph negative 1, negative 9. Boy, I hope I counted that correctly. Let's check that. 1, 2, 3, 4, 5, 6, 7. Yep. So that's negative 1, negative 9. And then here's 0, negative 8. Now, I know you got 2 points and they're pretty close together, but remember, a parabola is always going to, well, it's always going to have that same shape. I don't know if I really want to draw it yet, but I just want to remind you that there is a symmetry point that is guaranteed to be on the other side here. It wouldn't hurt to find that point. Well, I just did. It's negative 2, negative 9. So, again, we're just trying to do the things that we've done before. I've got 3 points. Are you ready? This is the new connection, the x-intercepts. Bum, bum, bum. The x-intercepts. X-intercepts. Oh, yeah, that's always when y equals 0. Wait, when y equals 0 in this equation, that means I'd be plugging a 0 right here. Look what we have. I know, try to not get too excited. We have a quadratic equation equal to 0. You know, like the kind that we were just solving yesterday? Yeah. I can take my x squared plus 2x minus 8, and I can figure out what makes it equal 0. Remember? We have to use this strategy, this factoring strategy. That's the whole reason we're studying this. So numbers that multiply to be negative 8, but add to be positive 2. I've got this thing factored. I'm ready to solve it. Now remember, when you solve it, you're really coming up with the numbers that are going to make each group equal 0. It basically looks like the opposite numbers. But what are these? That's right, they are the x-intercepts. Check it out. They're the x-intercepts. Even if you graph them, you can see 100% that your parabola is going to pass through those x-intercepts. I mean, now I can actually draw my parabola And even the shape itself affirms that those two x-intercepts, once again at -4 and +2, were destined to fit that parabola. Honestly, that's it. That's like the new idea today. I think at the bottom of your paper, do you have a spot for this? The x-intercepts of the parabola are honestly going to be the solutions, the roots, the zeros of the quadratic equation when it's equal to 0. Again, the x-intercepts end up being the values that make the equation equal 0. Well, pretty cool. We will come back to that idea, although it'll be the same idea, but we'll come back to it and we'll really hammer it. But for today, that's it.